Hey everyone, welcome to the next Earth Science review video. This is going to be video 29 in the series, and we're going to be talking about beaches, landscapes, and deposition today in the fastest way possible, giving you that most important, efficient information that you need to do well. So without further ado, here we go. So for beaches, we're going to talk about longshore currents for a second. This is just the fact that the waves hit the beach at an angle, and it causes everything to move down the beach. So, like, if the water was here and the beach was here, the water hits the beach at an angle. So, depending on the situation, it could either be diagonal to the left or diagonal to the right. Second thing to know about beaches is that the water breaks down the rocks near the beach, and depending on the resistance or hardness of the material, it's going to be broken down at a different rate. And this is how mostly everything gets formed around beaches. Like, some rocks more resistant than others, so they chip away faster than others, and it makes these cool structures like headlands and bays. And it also makes some structures like sea stacks like this. It's all the same concept that some rocks erode or weather away faster than others. So if the beach is being eroded too much, they could build these things called groins or jetties, and what they do is this giant thing of rock you could see that is put out into the water, and we build them. And what happens is the longshore current comes in this way, and the sand gets trapped over here, which builds the beach back up over in this vicinity. However, on the other side, this area is starved, meaning it would normally be getting all this sand, but it's not. So it's like a balancing act. So depending on the direction of the longshore current, there's going to be deposition on one side of the jetty, and there will be a starved area on the other side. Here's some pictures of jetties and groins, more jetties. Again, like this picture here, since there's more sand on this side, I know the longshore current's coming in on this angle, because it's going to drop it off all here, and then this area here didn't get that sand. Next thing to know about beaches is these things called barrier islands, and the reason that this is important is because we have one underneath the Long Island here. It's this whole area. Barrier islands are depositional features, but they also protect us against storms. It's like our first line of defense. So essentially the storm destroys the barrier island before it actually gets to the area, like here where all the houses are, for instance. So here's Long Island with the barrier island on the southern shore here, right here. All right, this is the landscape regions map on New York reference table, page 2. And this map here is page 3. This is generalized geology, but these maps are both going to be used back to back. So essentially you can find out, like Old Forge, for example, they could be like, oh, what landscape region is Old Forge in? You would find Old Forge on this page 3 map and go to the same exact spot on page 2, which is in here. So the landscape region of Old Forge is the Adirondack Mountains. And they can do this for any city. Like you could do Rochester. Rochester's here. Go to the same spot on this map. It's in the Erie, Ontario lowlands. So you could see if I flip real quick, it's the same map, right? But different information on both maps. All right, for deposition and landscapes, first thing to know is that things that are in streams are sorted by size. We talked about this in the last video. A couple of new relationships. The bigger the particle, they would settle faster than a smaller particle. So a boulder is going to sink faster than a piece of sand. The next is shape. The flatter the object, the slower it's going to sink. So rounder objects sink faster than flatter objects, and that's because this has a bigger surface area, so it's like resisting the water more than a rounder object. So this is going to be slow for the flat particle. And this one sounds obvious, but the denser the particle is, the faster it's going to also sink. All right, so streams sort horizontally when they deposit. They can also sort vertically depending on the situation and the season. And we're moving on to landscapes. So the landscapes are going to be really generalized by how much uplift there is, meaning how much of the land is being pushed up, and then how much of the land is being flattened, which is called the leveling force. And the leveling forces are generally like wind, water, things that are moving sediment and like flattening it out. So there's pretty much a battle between how much the land can lift up and how much the land can flatten out. And depending on the scenario, either the leveling force is going to win and you're going to have a flat landscape, or you're going to have the uplifting forces win and you're going to have a very mountainous landscape, or you could sort of get some mixes. Now, if they cancel out, we call that dynamic equilibrium because one process is happening at the same rate as the other. It's like if you take your hands together and you push at the same strength, that's equilibrium. Like neither hand goes anywhere. So if you get more uplift, you're going to have a mountainous area. If you get more leveling, you can have plains or plateaus. Plains is the most leveling. Plateaus is like a medium amount of leveling. Now, the big thing about bedrock or topography, or the way that the land is shaped, is going to be two ways. First of all, the climate of the area. So a hot, dry climate will have different sort of land than a rainforest area. And the type of rock. Remember, some rock weathers away faster than other type of rock, which really makes a big difference. All right, couple landscape facts. So landscape is the general shape of the region. So you got 3 types of landscapes in New York that you got to know. Mountains, plateaus, and plains. So mountains, we should know. They're like the ones with the peaks. Plateaus are like flat mountains, but they're not really that tall. So they're like squares like this. And normally you're going to find them in deserts. And then plains is just flat. So here's your mountain. Steep slopes. Uplift is going to be your major thing that's creating them. Plateaus. Here's a picture of them. We got some in New York State. The Catskills are plateaus. They're like rolling hills sort of thing. Like this. This is a canyon. Another plateau. And our plains are going to be flat. Got a lot of streams on it. Like this. And here's an example of how the soil or the climate and the bedrock affect what it looks like. So generally, here's your example for humid areas. So like forest and watery areas, you're going to have flatter, more fertile soil, and sort of like foresty area. And then your arid, which means dry, this is going to give you your plateaus, your steep, your rocky, desert-like qualities. So you could see like the topography, the shape of the land is very different between these two climates. That has to do with the weather and the type of bedrock. Speaking of bedrock, the bedrock in an area causes streams to drain in certain patterns. There's 4 patterns that you guys need to be able to identify, and here they are in one little cheat sheet. These are the only 4 you're ever going to see. So you're going to have to remember these. You don't have to remember the names of them. You're just going to have to be able to pick the correct picture, which I'll show you an example of in the question. But this one sort of looks like a tree. This one's all like blocky, sort of like this. This one down here has straight lines with little rivers coming out of the left and right. And this one here is the water dripping down each side of the hill. So here they are again. And at this point, we can get into our practice questions. So like I always say, pause the video, try to answer the questions, and then play it and see if you get it right. So number 1, which profile best shows the general pattern that occurs when water from a stream enters the ocean? So remember, it's going to be sorted by size, and it's always going to be from largest to smallest. So we want the boulders and the cobbles and the pebbles, sands, silt, and clay. So this looks like sand, pebbles, clay, silt. That's going to be wrong. We want pebbles, sand, silt, clay. So D is going to be your best answer. Number 2, a sedimentary particle is dropped into a cylinder. The particle that will take the longest time to settle, which would be what? The longest time to settle, we want the lightest one, generally, and the smallest one, and the flatter. So the best answer here is going to be low density, small size, and flat. The one that would go the fastest is going to be your high density, large, and spherical. That's your fast. Number 3, deposition within a meandering stream usually occurs on the inside. Why? this sort of question from the last video as well. The inside of the curves has the slowest velocity. Slower speed means that the river's not strong enough to move, so it just drops it off. All right, we got depositional features. Picture A, picture B. They want you to name them. All right, you should have gotten A as your river delta and B as a barrier island. Number 5, which section best represents a plateau? All right, well, we saw some pictures in the video. Hopefully you got C. C is your plateau area. Number 6, we got a volcano. They want you to pick the stream drainage pattern that would flow down the volcano correctly. Well, we talked about this in the stream drainage section. The best picture is going to be D for this one. Number 7, you need your reference table. That's your hint. And you need page 2 and 3 like we talked about. Based on the map, in which New York State landscape region is Mendon Ponds Park located? And I will give you a hint, you got to use latitude and longitude. All right, well, it looks like we're around 4377. You know, the minutes are going to make barely any difference because we're in with like 1 minute each way. So I'm just going to go to 4377 on this page. So 4377. So we're in this area here. And if you go to that same area on page 2, we are about here in the Erie, Ontario lowlands for our answer on this one. So C. All right. Which term best describes the landscapes of A, B, C, and D? So you have to look at these and pick the one that would define it correctly. All right, well, hopefully you got the answer of A. Mountains is the great relief and high peaks. Ridges and valleys is going to be rounded peaks, wide valleys. And then, first of all, it says the answer there. Plateau is moderately high to high relief, and you got that horizontal flat bedrock like this. And then you got your plains, which is going to be flat. And we got 2 landscapes, so we saw a picture of this. The difference in the landscape is going to be what? Now it says mainly, so you got to pick the best answer. Climate is going to be your major factor here. That's going to make a difference. There's clearly trees here and none here, so this is probably going to be your arid desert. And this would be like your forest with your moisture. And we got last question. So we got our groin here, which is our barrier that's going to trap sand. And it says the groin structure will change the pattern of deposition, initially causing the beach to become... All right, remember the Longshore Current, they show the arrow here. The Longshore Current's going this way, so the sand's going to get trapped here, and it's going to be starved on this side. So we want wider on the, look, this is east, wider on the eastern side. So B is your right answer for that one. All right, guys, I hope this helped. Remember, this is just a little taste test. You know, it's not going to supplement for actually studying all of your stuff, reading some stuff, watching the video multiple times, doing practice questions. You should know the drill by now. All right, if you have any questions, let me know. Good luck. See you later. Bye.